face, but I didn't realize that you're really...
It's me. I already saw that you signed up like some days ago, and I was like, wow, this is really cool. It's like getting the old family back together. Matt, do you know Ollie? No, you probably don't.
No, I don't think so.
No.
He was the CTO of Immobilien Scott long before Richard joined.
Die Welt ist klein.
Yeah.
Small world.
Absolutely.
Let's see what you're telling us today.
I think you only left when I joined in 2012, right?
Bastian, I think I know your face.
Yeah, we had one or two conversations, right? But
I know your face, yes. That were the happy days. After this, I joined Postal Services.
Yeah, exactly.
This was a very political environment.
So it should be live on YouTube now as well. Maybe you can check the link.
Yeah, I was wondering why I hear myself like 2 times, but now I know because the YouTube stream was on as well.
Which means we need to stop talking about private stuff.
Yes, so I will share it there as well, and then.
So shall I also start the recording already?
Yeah, I don't mind.
I do. We go, rolling. So all the setup is prepared. We have it on YouTube. You have it in the Zoom session. So I will keep myself back now as the technical host and open the stage for you guys.
Wonderful, thank you. Are there people waiting already, Peter, or?
No, I opened the waiting room. They can join immediately. I don't need to admit it. So I see 12 participants already, 13.
Yeah, so we have 130 invites.
Siska ist auch dabei. It's also there. Small world.
Spent one night with Rosalind of unlocked ancient fairy magic. Magic we thought was lost. She told Bloom the settlers busted among like civilians, they were blood witches. Details she chose not to tell us at the time. They were blood witches.
Where's this coming from?
It sounds quite interesting.
It seems someone has realized that sound was on.
Secretly watching Netflix on the other screen.
Hey, Peter, how many people are we by now?
Now it's 25, but you should also be able to just open the participants pane, then you can see it.
Yeah, I messed up my screen a bit, I have to say.
Hello.
Hello. All right, for everyone who's there, welcome already to today's session. We give everyone else 2 more minutes to join before we start, because we don't want to steal too much time from Matt's presentation, so he doesn't need to rush. But I think 2 more minutes should be fine for everyone. Oh, there's someone outside enjoying blue sky.
This was atop the Himalaya. We crossed there.
I see some very familiar faces.
Hi, Jess.
Hello, Suresh. Hello, Arun.
Hey guys, nice to see you all.
Hi, Arun. I didn't know which Arun she was saying hi to. I know a few in Berlin. So.
Hey Suresh.
Hi.
Hello, Lilia. So I think we just get started. People might join later on, but we also want to be respectful of all of those who were on time. So welcome everyone to today's session. I am one of the co-founders of the Mentoring Club. Bastian, who is also in this call today, is the other co-founder. So speaking for both of us and saying welcome, very warm welcome to our first talk of this year, in which we are actually very excited because we have a guest speaker, Matt from ThoughtWorks, and he offered to speak about machine learning and product management on a pro bono basis, which is particularly which is particularly great for us because we are a nonprofit, so we rely on others being willing to help and pay back to the community, which Matt gladly joined us in today. So Matt, very warm welcome to you, and already from all of us in our Mentoring Club community, big thank you to you and also ThoughtWorks as a company in general. We look forward to hearing about machine learning and product from you. And with this, I would also like to hand over to you to not waste any more time and give you officially the mic. And for everyone in the audience, I hope you enjoy the session and have an insightful lunch break.
Thanks, Jess. Hi, everyone, and thanks for the opportunity to speak to you this lunchtime. What I'm going to talk about today is machine learning, but particularly for product managers. So what this isn't is a kind of deep tech talk on machine learning, and it's also not a kind of big vision strategic talk on machine learning. The reason that I put it together with a colleague of mine who's Matt Kelsey, who's from more of an engineering background, is that we felt that there's a lot of talks about machine learning, but often the kind of practical reality for product people got missed between those two kind of poles, that really academic technical pole on one side and then the big strategic vision pole on the other side. So we wanted to do something that was really kind of practical and hands-on, and hopefully helps product managers think about machine learning in a different way and a really kind of accessible way. So what I will cover today is kind of 3 sections. And what I've done is really just lifted the 4 kind of classic product management lenses, so the sort of muddy cake and, building on the IDEO kind of thinking about how you should think about a product, what you should be considering as you're exploring a new product. So those are technical feasibility, the value for a customer, the commercial viability of that potential product, and then the usability of that product. So those are the sort of 4 lenses that classical sort of tech product thinking would say that we should look through when we're considering an idea. So I'll build the talk around those 4 things, but I'll also start up with just a definition about what we mean when we talk about machine learning. And then finally, I'll cap it off with just a kind of a perspective on strategy and how you can kind of consider the product from a strategic point of view, particularly with machine learning opportunities. So with that in mind, let's get started and start with that definition. So what is machine learning? So there's a lot of terms that float around and I think get used almost interchangeably. So, AI, artificial intelligence, machine learning, data science. And, I think that sometimes is the start of confusion for product people in kind of building machine learning into product opportunities, is even just the sort of barrier of, what are we talking about and where do we start? So there's often a lot of hardcore maths associated with it, but what I'm really going to be talking about today in sort of simple terms is machine learning as a set of tools, algorithms, techniques for asking questions of data and then incorporating the answers that are returned into a product experience for a user or a consumer. So to make that a little bit more tangible, let's have a look at an example. So the really simplistic example, and this is betraying my real estate marketplace background, is an example of where we're using machine learning to predict the price of a house. So this uses probably the main kind of flavor of machine learning that we see in a kind of business context at the moment, which is supervised learning. So what this means is that on the left-hand side, we've got some data. So these are things that we know, and then on the right-hand side is the thing that we want to know. So what's the likely sale price of that last property in the bottom row? And what sits in between, what we know and what we want to know is the middle piece, which is the model. And that's what maps the inputs on the left to the outputs and the answers
Je venais voir en fait
on the right.
S'il était toujours là, pour mettre le four à chauffer.
I think we've got JB, maybe you can go on mute. Thank you. So that's the broad structure of what we're talking about, and that's what I'm going to be talking about when I'm referring to machine learning. And I'll come back to this pretty sort of simple example to kind of anchor us in the thinking. So let's go into a bit more detail with the first of those product lenses. So that the first of that product lenses is the technical feasibility. So this is if we're considering a product idea, we need to think about whether it's technically feasible. So how can we look through that lens of technical feasibility in a way that's particularly relevant to machine learning products? So I'm going to refer to this chart a number of times in the talk, so I think it's worth just sort of taking a moment to get our heads around it. And the reason I'm using it is because I think it illustrates the two key components of a machine learning application as it's used in product. And they are on the vertical axis, the model, which I talked about before, the thing that's in the middle, and then on the horizontal axis, the data estate, so the data that's used. So these are the kind of two key components. The data that was on the left-hand side of that house example, the model that sits in the middle, and how we evolve these two key components will determine how effective the machine learning product that we're building is. So what I've illustrated there is a kind of investment path through those two. So what we often need to do is invest in data and then invest in the model to make the most of the data that we're incorporating, then go back and invest in developing the model to take advantage of that data, add more data, and you get this kind of tick-tacking effect where you improve the experience by investing in those two key components of the technology. There's a couple of things to note when we're thinking about it in that way, is that there's likely a minimal level of data that's required. So, there's a kind of a floor in a minimum set of data that you need to get any sort of experience. So, the chart that I've shown there doesn't entirely represent that. It indicates that you can build it up, but there probably is a minimum set of data that you need. The other thing that the chart doesn't really highlight is that there's usually diminishing returns in the quality of the impact that you get from adding more data. So broadly, it makes sense to add data, improve the model and develop in that way. But at some point, there is a kind of curve in terms of the return that you get from adding more data. So let's think about those two components of the machine learning experience in a bit more detail. So let's start with the data component, which I've illustrated as a single axis, but there's really two dimensions to that data estate. And the first of those is just volume. So this means that you can improve that data estate by adding volume. So in this example, we've added another row to that table, which is another property sale price, which is going to add another element or another piece of data volume to that existing set of data. Generally, more data will give you a better result. And often it's the easiest thing to do is if you're looking to improve that data estate, is to add more volume, because it means that you can fit within the existing processes that you've built. You don't have to make substantial changes in order to add more volume. It's also worth noting that in some cases, you can almost accidentally add to that volume of data. So where you've got an experience like a recommendation system where the interactions of the user effectively add more data to the data estate, you get this kind of happy virtuous cycle where you get that increased volume of data for free as part of that feedback loop. The other way that you can add to the data estate is by adding complexity. So, if we think about this sort of simple view of a table of data, this is about adding another column to the data that you've got. So in this example, we've got, what's the size of the yard that property has? So that adds another component of data, another piece of complexity that can be added to the model and gives the model another data point to reference to better refine that sales price that's the answer that we're targeting. This is in some ways a more expensive way to add to that data estate because it likely involves changes to the data collection and processing that you need to do. It's also worth noting that there's a kind of ROI question in doing that, in that not all data will have the same impact on the quality of the output of the model. Some data will be effectively redundant. It doesn't add any more clarity, and so you won't get the same return that you may get on another piece of data that makes a significant difference to the model. So that's the sort of view of the data dimension. How can we improve that data estate? And there's two broad ways we can do it. We can do it through volume, or we can do it through complexity. So now let's look at the other axis that I talked about, the vertical axis, which is the model. So the first thing to, I guess, be aware of is that we talk about a model, but effectively it's very rarely going to be a single model. It's almost invariably a series of models that will often produce data that will then input to other models. So it's a much more kind of messy and complex architecture of those different models. It's not a single nice clean model. And then the other thing that I think is important to consider when thinking about how you can improve the quality of that model and move up that vertical axis that I illustrated before, and that's where does that model come from? So there was a point 10, 15 years ago where almost all models had to be built largely from scratch. We're now at a point where there's actually lots of options in terms of the models that we use. The first of these, the easiest of these is cloud services. So all of the big tech players, Amazon and Google and Microsoft, now offer access to standard models that solve really common machine learning problems, like computer vision, the one on that's illustrated on the right, for a fraction of a cent, which is a massive change. If you think that even sort of 10 years ago, the amount of investment to get that quality of machine learning outcome would have cost a fortune for a business to invest for its own product, whereas now it's a service that we can all access as long as you're happy to use models that have been trained with other people's data, and as long as you accept that you'll effectively get no real competitive advantage out of those models because those models are freely available to everyone else. And as long as you're looking at solving, a fairly common standard set of machine learning problems. So, the top set of models there are the easiest ones are the cloud-based services and implementations of fairly standard models. The next level that we can take on in terms of making an investment is to tune an existing model. And so that may be taking a model that's been developed and published and is well understood, but you're tuning it to use your particular set of data. And it's running on your machinery against your data. And so you are adding some competitive advantage and some connection to your business that does develop that model as your own. And then the last level of investment that we can make is to build something from scratch, which potentially gives the best outcome, potentially allows you to be truly innovative in your product, but it's likely to come at a pretty significant cost in terms of the development and training of that model. So hopefully that gives you a sense of the two dimensions of technical feasibility for machine learning and what we can do to invest in those two technical dimensions and what we would need to consider as a product manager when thinking about the technology that would underpin a machine learning product. So I'll now move on to the second of the four lenses that I want to talk about. And that's the one that's probably kind of closest to the heart of most product managers, which is customer value. So I think that this is the one that we most often get wrong as product managers. It's the one that we're often most optimistic about and often overestimate the value of our products. So let's look at this in some more detail in the context of machine learning. So we go back to that chart that I talked about before, which has the model development on the vertical axis and then the data estate on the horizontal axis. And what I've done is just added another element to the chart, which is the bubble, which is the customer value that we get at each point. And the point I'm going to make is, in a lot of ways, is quite obvious for product managers because it's standard good product management. But I think it's surprising how often it gets missed when we're building machine learning products. And that's just that the value that we're delivering to customers needs to go up every time we make a step either across the horizontal axis or up on the vertical axis, because that's where we're making an investment and we need to see a return on that investment. It's only worth doing if it improves the customer experience. Importantly, we need to be able to measure that customer experience. And I think that that's something that we often don't do with machine learning products. And I think the best way to do it is to measure the experience that's delivered by a non-machine learning product. So that might be, if it's a recommender system, what happens if we just have a rules-based system that says, show other products that are in the same category that are at approximately the same price. So it's not machine learning, it's just based on a rule. Or what happens if we're building a tool that helps our employees complete a process faster by augmenting that experience or making a recommendation. What's the time that's taken to complete that process without that augmentation? And that gives us the baseline that we then need to hold ourselves accountable to as we invest in those machine learning products. And what I think we often see is that we see a kind of a sweet spot that's in the middle of that chart. And if we either overinvest in data, it takes us outside of that sweet spot, or if we get too excited by the sort of the maths and the academic kind of problem solving of the models, it takes us out of that band. And we know that we're out of that band because we don't see the same increase in customer value. And so that creates the sort of guardrail that we need to stick to. And more often than not, it takes us through that sort of that middle path. So there's a few kind of common patterns that we see that I think are traps for us to look out for. So I'll go through these in turn. And the first of these is what I've called the stalled value trap. And what this looks like is that you're continuing to invest, you're continuing to move, up and across to the top right, but you're not seeing that same increase in value. Effectively, we're chasing value that we can't achieve, and we should just stop. There's plenty of problems out there that can be addressed with machine learning. So there's no reason to kind of flog a dead horse and continue to try and solve the same problem. The second kind of anti-pattern that I think is worth looking at is the hype trap. And what this looks like is that you've actually got a pretty good customer experience based on a non-machine learning product, but there's a desire within the organization to build something with machine learning. So we get into this sort of hype trap where we may eventually increase the value. So we do eventually kind of achieve those blue dots in the top right, but the incremental improvement is not big enough to justify the investment. And so, we really have to look at this and say, what made us think that we could increase customer value to a point that justified the investment that we made. The next one, which isn't really an anti-pattern, but I think is worth thinking about, is the moonshot pattern. And what this looks like is that you get very little return in terms of increased customer value until you get a massive payoff at the end. And this is what we're seeing with the level of investment around things like autonomous driving. And clearly a lot of great companies are making that big investment. I think some of them are getting a little nervous at the moment, but it's pretty clear that we will keep investing in order to achieve that moonshot. But it's important to understand whether you're in an organization that's got that level of resources available and that level of commitment that means that you're going to get to that big payoff. Because clearly, if you look at that chart, there's no value in stopping halfway through that process. So this is where a sort of agile approach may not work. Although we should also consider, what other benefits do we get? So even if we're not at level 4 autonomous driving now, has it helped us with adaptive cruise control or lane assist or other benefits? So maybe that example is not so much the moonshot pattern because we are getting value delivered. Which takes us to what I think is the best approach, which is a complementary approach. And it comes back to the point from before where we looked at the technology lens and the feasibility, is that it's unlikely that there is just a single model that you're betting on. And that means that you may be able to take multiple approaches. So you can do the more iterative increase at the same time you're looking to deliver that moonshot. So that's how I think it's useful to think about customer value when it comes to machine learning, and it's really just a kind of call to continue to do what good product managers do, which is be super clear on customer value and the level of investment, which is not always what we do when we're tempted by the kind of excitement of machine learning opportunities. So the next lens that I wanted to cover was commercial viability. So this is, are we getting the business return from the investment that we're making in the machine learning product that we're building? So we'll again look at this chart. So if we focus on the horizontal axis, so this is the bespoke data estate. And the thing to consider when we're thinking about the commercial viability of the machine learning product in terms of data is, what's the cost of moving along that axis? So if we want to move from left to right, what do we need to achieve? And I think there's two significant costs that we're going to incur and that we're going to want to understand. So the first of these is the one that I think is sometimes a surprise, is the people cost around data engineering. And we incur this cost pretty much at the beginning. So, you immediately need, even to deliver the smallest machine learning product, you need to access the data that you have. And often that data is theoretical. So often when you're thinking about a machine learning product, that theoretically your organization has this data, and it probably does in a data store somewhere, but it's likely you'll have to make a significant people investment up front to get that data accessible, so you can even just do the basics. So as soon as you start moving across that axis to the right, you hit that big people cost. The other sort of big category of costs that we'll have is the data storage cost. And the good news on this is that this is much more connected to where we are on that axis. So as we move to the right, cost goes up as we add complexity and as we add volume, but it's a pretty linear impact. So we'd expect that as we're moving across, we're getting the payoff, so we're happy to make that investment. Whereas the people one, we hit that up front. The second big set of costs that we need to think about are moving up the vertical axis. So, as we kind of move from bottom left to top right, we need to move up the vertical axis. So we need to invest in that model investment. So again, there's people and technology costs very, very broadly. And so let's start with the people ones again first. And this is probably the sort of good news, I think, from a cost perspective, is that the beginning of that access may well be free. So that if we're using those cloud-based standardized models that have been pre-trained by a provider but solve common machine learning problems, you probably don't have to do any people investment in developing that model. The only cost that you have is the cost to use the service. So that's the small cost there you see on the compute side. As you move up, you start moving away from those standardized generic models, and you start either training standard models with your own data or getting to the very top of that axis, which is when you're actually developing your own unique models or unique combination of models. And so this is the point where those people costs get extremely high, because they're obviously very specialist people that are hard to recruit. We need to pay them a lot of money, but that comes quite a long way down the process for most of us building machine learning products. The compute costs are fairly connected to where we are on the axis. So they will go up once we're starting to train with our own data, and particularly when we're adding really big volumes of data. But it's where you're starting to get the payoff, so it's probably less of a concern from a commercial perspective. So that's a look at the cost structures, which I think are the main driver of the commercial feasibility. I think it probably is also worth noting that there are important ethical and regulatory considerations that we have to make in this space, but I haven't really touched on it here because I think that's it's a whole kind of talk in itself, and there's a lot of great material out there about the ethics of machine learning. So I won't touch on that in this talk, but it is part, I think, of the commercial feasibility consideration that we need to make. Okay, so let's move into the last of those lenses, which is the usability lens. So I think it's pretty hard to be very specific about usability because it obviously depends on what we're building. So I'm not going to, not trying to sort of anticipate the details around usability, but I think that there is a kind of common consideration that applies to all the machine learning products that I've been involved in. And what that is about building an experience that reflects where you are on that chart, where you are from sort of bottom left to top right. And what that really means is it's about being robust to failure. So the example that I've got here is from the YouTube recommender. So someone's watching Aaron Ramsey back when he was playing for Arsenal. So the example's a little bit old. And if you look at the recommendations that the recommender is making on the right-hand side, so what you can see is that there's a range of different recommendations that are made. So they vary from like a particular player, Zidane, through to, football humor, generic football topics, generic sport topics, back to more generic football topics, and then back to a particular player, Zidane again. So I think what's interesting to think about here from a usability point of view is that it's a pretty kind of polite interface. It's acknowledging that there's a range of things that the user may be interested in, and so it's really about kind of augmenting the experience rather than taking over the experience. And I think that that's a really good way to think about how usability of machine learning systems evolves. It's similar to like autonomous vehicles in that you start off by augmenting the experience, helping someone with parallel parking or helping someone with motorway driving rather than trying to completely take over the experience. And what that does is that it's making a much smaller kind of claim on the experience. So if you get it wrong, the user can choose whether they're interested in Zidane or whether they want to, watch a humorous football video. So you're not being as kind of presumptuous. And I think that applies to lots of machine learning experiences and interfaces, that you start small and you start by just kind of politely trying to augment the experience rather than really take it over. It's a little bit in contrast to the autoplay that you get in this YouTube recommender interface. So this is a more kind of presumptuous experience. It's much more like, this is the video that we think you should watch next. We're not augmenting and just presenting 6 options. We're saying, we think you should watch this one. So it's this sort of interface is more appropriate when we're more confident. So when, if we go back to that same chart, once we get to the top right, we're much more confident in terms of the UI, and we're much more in a kind of automating the experience rather than augmenting the experience. So, as the product gets better, as we're more confident in it, we can have a more confident UI. Okay, so the last piece that I wanted to talk about when considering considering machine learning for product managers is kind of stepping back from the specifics of the product. So those first 4 lenses are really about, we've got a product idea. How do we need to think about the product and its likelihood of success? The other consideration is strategic. And this is really kind of stepping back from the specific product and thinking about, how can we use machine learning in a competitive context or a strategic context. So the first thing that I think is interesting about machine learning is this double flywheel effect that is really powerful from a competitive point of view. So, the concept of a kind of flywheel, a strategic flywheel, I think is common to a lot of products. And that's the kind of inner flywheel that you can, or the inner sort of virtuous cycle you can see here. And what that looks like is that you build a great experience. So you start off with that strong experience quality that generates usage, and then you're able to monetize that usage. So you generate revenue, which you can reinvest into the product, which allows you to innovate, either in terms of the model or in terms of purchasing more data or better data, which then reinforces the experience quality, and you get this nice kind of cycle that turns over, and it's hard for competitors to disrupt that. So that's a kind of pretty common, I think, cycle that any successful product has with generating revenue that can be reinvested in the product. The interesting thing I think about machine learning is that you get this additional kind of flywheel that goes in the same direction, which comes around data. So you build a great experience, it generates usage, and that usage then generates its own unique data. So that could be something like, for the Google search experience, the data they have around what search result gets clicked on for a particular search term is the strongest input into that search. And that is basically just leveraging data that they've generated in huge volumes and illustrates how that data then informs the experience, which then drives usage and then drives more data, as well as the money that you can invest. So I think that that machine learning has this kind of double flywheel, which makes it particularly attractive to get to first. So I think that's some of the hype around machine learning is because of this, because there's a sense that you get there first and get the usage, and it'll be very difficult for others to catch up. So to expand on that a little bit more, where is the competitive advantage with machine learning products? And I've gone back to this same visualization and just illustrated it with the dark red is where the strongest competitive advantage is. And clearly, the further you get towards the top right, so the better product that you build, the more competitive advantage there is in that. But I think that the other important takeout from this chart is that there's more on the right-hand side than there is on the top. So I believe there's more potential for competitive advantage in data than there is in models. So it's really only when you get to the absolute top of that vertical axis where you're creating completely novel models that the model delivers you real competitive advantage, where I think you can get competitive advantage out of data much sooner. And that's why getting there first and starting to generate particularly feedback data that comes from the usage of the system is particularly attractive. The last slide I wanted to talk about in terms of strategy is just where to look for opportunities. And I think that there's broadly two kind of categories that we see coming up again and again. I think the first one is value creation. And so this is where the investment in machine learning creates the kind of core value of a product. So this might be things like voice interfaces or self-driving vehicles. Machine learning is actually changing the kind of core value of the product. I think this is particularly attractive in terms of creating that flywheel. So because it's at the core of the value of the product, it's got the potential to create that usage data that then feeds into the experience. And so that makes it more urgent to explore, but it also makes it riskier. It makes it more of a moonshot. If it's not successful, it's less likely that you get a partially successful product. It's more likely that, that the product will be unsuccessful. The other opportunity to look for is around efficiency. So this is where machine learning is not delivering new core value to the product. It's actually making an existing product or an existing business more efficient. So this might be things like process prioritization or fraud detection. So if you think of an example of safety inspector who's looking for electrical faults, machine learning can advise on which system to look at first. Whether photos of lots of systems, which one is most likely to be at risk. Which makes it more efficient, but it doesn't completely change the value of what that inspector is doing. There's less opportunity, I think, for that kind of flywheel effect. And so it's more likely to be incremental and replicable, which means there's also less urgency. So I think the good thing about this is that there's less of a kind of gold rush mentality. There's more opportunity to make small improvements, which fits with that more iterative approach of moving up towards the top right. It's also likely to be more proven. There's more opportunities to use existing technology in a different context to solve existing problems. Okay, so the last thing I wanted to talk about before we wrap up is just this kind of question of, is this a time where we should be tech-led? And I sort of say this as a product manager, and I think generally believing that product people should start with customer problems first, and then we should think about how we can solve that with technology. I think that machine learning is an area where we're getting a lot of pressure not to do that. And I think that we're getting more pressure to start with the technology and to then think about how we can apply that. And I think that this makes sense. And I think that this is a place where it's kind of okay for us as product managers to sort of, to break the kind of mantra that we should start with a customer problem. And I think that's just because there's a gap in terms of our intuitive understanding of what problems we can solve with machine learning. So we need to kind of kickstart our own understanding of what's achievable. And for that reason, I think it does make sense to sort of start with the technology and take a kind of boot camp sort of approach, which is really about not implementing machine learning at any cost, but it's about lifting the kind of baseline understanding of product people and of designers and salespeople and everyone across the business, sort of breaking out of the the sort of specialized data science team that we might have, and uplifting the level of understanding so that we're aware of what can be done and we can anticipate it when we go back to focusing on those customer problems. So I think, if you do have a sort of CEO or a founder who just wants some AI, I think that this is an opportunity where it's okay to start with that kind of boot camp and try and understand where the opportunities might be, as long as we then go back to the customer problem and we look at that value and make sure that it's delivering with the investment that we make. Okay, so I think we've got sort of 10 minutes to go, so I'll wrap it up there. Just to reiterate, what we covered today was a view of what practically product managers can think about when considering machine learning. So it's not, it's not a sort of deep technical view, but it's also not a big picture strategic view. It was hopefully gave you some tips on what we can do day to day to get started with machine learning. And the way I did that was to just talk about those 4 classical, Marty Kagan lenses of product management, and then to finish up with thinking about strategy. And we kept coming back to that idea of these 2 dimensions, the 2 axes on that chart of data on one side and model complexity on the other, and a view that we need to get to that top right, making sure that we continue to deliver value to our customers. So thanks for the opportunity, and I'll perhaps hand back to Jess and see whether there's any questions or any discussion.
First of all, thank you so much. I really enjoyed listening to your talk over the last 45 minutes. I'm sure everybody else enjoyed it just as much as I did. So again, big thank you for all the insights that you shared with us today. And I'm sure there are lots of questions, and I'll just break the ice by asking you, what do you think, how does the machine learning as a capability for product managers change over the upcoming years?
That's a good question. I think that we will, hit a point where ethics become almost the first kind of consideration. I think that we're in, I guess, that sort of early stage where there is that kind of gold rush mentality, and people are trying to gain that competitive advantage. So there's a sort of rush to it. And I think that we are starting to see the impact of that. And I think it fits with the wider position of kind of big tech in society. So I think that's likely to become a kind of first order problem. And I think that we will have to invest much more in making models explainable and justifying the outcomes of those models. So I think we won't be able to get away with as much kind of black box machine learning products where we get a good result that works, and that's the only consideration that we have to make. I think we're going to have to be much more intentional about how we got there and what that means from an ethical perspective.
Thank you. So I will open up for others to ask questions. We have 5 more minutes. So if anyone wants to ask Matt anything, then please unmute yourself and go ahead.
I just want to say it was an excellent talk, as is Rashir. I'm a data science leader, and I think this was wonderful. I think the 3 things that really stand out describing data, it's amazing because I'm preparing a presentation to introduce my new team at my new company. And I talk about data, volume, correlations, and unique. You said complexity, but it's the same thing. And it's amazing. And that applies to actually a company itself, right? I mean, that's what we aim to do. So it's really a great tagline to just say, what we need in data is exactly what we need in the compey. So wonderful.
Thank you, Suresh. Yeah, I appreciate it. Yeah, I think that it's I think we all benefit from simplifying it. I think that there's been a lot of, we've almost sort of created some barriers, where I think particularly kind of product people almost don't feel like they can sort of ask what's the sort of simplest terms of how it works. So so that's what we tried to achieve with the talk. So it's great to hear the feedback.
Thank you, Suresh, for your feedback. Is there anyone else in the crowd who wants to ask a question?
Yeah, I would also have a question. Hi, Jess and Matt. Thanks a lot for the talk. So I was wondering how much, let's say, data science knowledge you really need. Going into the direction, on the one hand, do you believe that the product manager also needs deep data science understanding beyond, let's say, the basic statistics understanding? And the other direction would be with all the new services coming up, at which point do we are at a point where maybe somebody without this data science knowledge would be able to, let's say, plug in the capabilities?
Yeah, I think it's a very interesting question. I guess I feel like the data science knowledge is probably less important than I thought it was when I sort of first became involved with machine learning products. And I think that that's changed probably because of two reasons. So I think one is the kind of standardization of like the top sort of dozen applications of machine learning. So if you think about like things like recommenders or sentiment analysis or computer vision or text-to-speech, these sorts of things, I think one thing that's interesting is that you can I think achieve a lot, and I think we're seeing a lot of startups that are just looking at that set of 12 kind of machine learning applications and just thinking about what's a different context that I could use it for. So you could use that image processing. You could use it to look for skin cancer on moles, or you could use it to look for faults in electrical systems. There's sort of almost an unlimited sort of number of possibilities. So I think one thing that seems to be sort of interesting is that it's like we've taken this big technical step. We've opened up all of these new, we've developed this sort of amazing technology that is sort of relatively limited in the number of things it can do, but there's almost unlimited application for it. So I think that's one thing I think that's interesting, is that you don't need to understand much about the data science of those things. It's more just like, how could I use it? And then it's, you can connect to the Amazon API and you can probably get a long way. So I think that's one thing that's changed my view a little bit. I think the other thing that's changed my view is how much work there is in the data engineering side. So I almost feel like it's like learning about data engineering is probably almost more beneficial than learning about the development of the models and algorithms, because I think that's the problem that you're most likely to hit first. And I think that's where a lot of products kind of fail, is because no one anticipated how much work there was in just accessing the data that we've already got. And it's quite hard to be iterative in that. You may have to make a substantial investment in just getting access to the data. And if that takes too long, everyone loses confidence and wonders whether it's worth it. So it almost feels like that's maybe a better area for product managers and sort of non-engineers to get an understanding of, because that's where they need to kind of be brave, I guess, and it helps to understand the problems, because I think you hit that before your lack of algorithmic knowledge or maths knowledge becomes a problem. good discussion point. That's a very sort of personal view. I think, the other thing I think that's a challenge is just how much maths is involved in it. So I think there's a lot of people who you just hit a barrier that's very hard to get through. Certainly I've found that.
Matt, also thanks from my side. We have one more question in the chat. Do you have time for answering this briefly?
Yeah,
so,
sure.
Because I think it's a quite a nice closing question. So, what, from your experience, are the main not to do's? So, what are the pitfalls? What do you think product managers, teams should avoid when diving into ML?
I think the biggest pitfall for me is having a separate data science team. And I think, and this is a little bit just sort of classic sort of agile cross-functional team kind of thinking, but I think we've ignored that when it comes to machine learning and data science, because it's often really hard to recruit these people. And so we almost feel like, let's put them in a special, center of excellence somewhere off to the side. And then I think you get this, this kind of conflict where this, sort of center of excellence is producing often like amazing creative models that never get into production because they don't solve real business problems. And then meanwhile, the product engineering teams who are focused on building things for customers get frustrated because they see, they see sort of expensive teams doing things that aren't having an impact. And so you almost get this kind of divide. So I'm a big believer in getting data engineers and data scientists into just standard product and engineering teams, because I think they'll be more motivated to see stuff get into production, and they'll also solve real business problems that will then kind of spread that knowledge wider in the organization. And so you get more familiarity, and then you'll start to solve more problems, and you get this momentum around it. So yeah, I think that's probably the biggest thing that I've seen go wrong, is treating it as something kind of special and off to the side. I think we're kind of beyond that now, where I reckon almost any product team could benefit from having those skills within it.
Thank you so much, Matt. We're out of time, unfortunately. I could also ask at least 3 more questions that are top of my mind. But I think some of us who are in European time zones might need to go to different meetings or finally have lunch if they didn't have it during the meeting here. But anyways, Matt, thank you so much again. We really appreciate the time and the effort it took you to hold this talk today. For everyone in the audience, we've recorded the speech. We'll make some final cuts and then upload it to our website, mentoring-club.com. So in case you want to watch the video again and just reinform yourself about all the stuff that Matt has said, feel free to visit the website by the end of this week. I think we should have it latest on Monday. And with this, I'd like to wish everyone a nice rest of the day, and hope to see all of you soon. And I hope you enjoyed today's talk. Bye-bye, everyone.
Thanks.
Thank you.
Thank you.